This is the screencast for section 6.3, example 1. So in previous sections, when you graphed something with vertical free fall, you saw a graph that had a big arch to it, but you knew that the object was just falling straight down. Parametric equations give us the ability to actually show the object's motion falling straight down. We get to graph x, the horizontal change, as a function of time, and then y independently, the vertical change, also as a function of time. So for example, if you have a rock that's dropped from a 420-foot tower, instead of looking at just its height according to time, as we have in the past with our vertical freefall equations, we get to actually watch this rock fall. And in this case, we picked an x coordinate of, I don't know, 2.5. Yeah, there it is, 2.5. So we said this rock is going to fall down a horizontal distance of 2.5, but its height is going to change according to this path, depending on how many seconds. So you can see after 1 second, its height is 404 feet. After 2 seconds, 356 feet, etc. On the next page here, I have, it looks really complicated, but it's not that bad. In the top, I have graphed this same situation as we have in the past, using the vertical free fall and upside down parabola, and you're not actually watching the rock's motion. You are getting an input of how much time has passed with an output of how high the rock is. But in your head, you have to picture its vertical path. When you graph on your calculator in parametric mode, so mode parametric, you get to see the rock's path as the seconds progress. So let's look at our own example. For the given parameter interval, graph the parametric equations x equals t squared minus 2 and y equals 3t. So this is the horizontal coordinates of this object are changing according to time squared minus 2. The verticals are changing according to 3t. So in my calculator, I put t squared minus 2 into x1, and then 3t into y1. And now I have to adjust my window. So first, my t min in part A asks for t values from -3 to 1. So my t min is going to be -3. My t max is going to be 1. Now the t step is going to be how often do you want the calculator to calculate the x and y coordinates. So 2 seems pretty fast because it would only calculate -3, -1, and then I guess that would, and then 1. So let's go to maybe 0.1, slow it down a little bit, have it calculate every value every 0.1. Now I'm going to stick with a standard viewing window, my x min and max be -10 and 10, and same with my y min and max, and see what happens. So I can see pretty much the whole graph. If I trace and then I look at where t equals -3, my x coordinate is 7, my y coordinate is -9, so 7 comma -9. And if you use the functions and plug in -3 and then for t, you'll be able to get the x coordinate at 7 and the y coordinate at -9. If I trace to see the t max at 1, I have the point x equals -1 and then y equals 3, so -1 comma 3. Now if I change those parameters to -2 as my t min and 3 as my t max, you're going to see there's some overlap. So you're going to see some of the part of the graph you saw in part A, but then a little bit more after that. Now I'm going to change my t step to show you what this means. I'm going to change this to 0.01, so you can see your calculator is now going to calculate it very slowly. See how it slows down? Last time it looked like it graphed it right away. So we see some of a similar graph to what we had before, but now we see more after that. Part C asks, let's go all the way. Let's go from -3 to 3. So I'm going to change my t min to -3. So now we have all of the first part and all of the second part, the whole big graph. The now try problem number 7 asks us to graph the parametric equations x equals 3 minus t squared and y equals 2t in the specified parameter interval. And we're going to use the standard viewing window just because they told us to. So I put in x1, 3 minus t squared, and then in y1, 2t. Now my window, my t min is going to be 0. My t max is going to be 10. That is not part of the standard viewing window. The standard viewing window doesn't include t steps or anything. It only means x min, x max, y min, y max. So those are going to stay at negative 10 and 10 respectively. My t step, I'll keep that at 0.01. That's a good speed. And let's see what happens here. So I can see that my graph looks like it goes all the way. I mean, it's still going. I can see my calculator was still calculating there. Just for fun, because, you know, math is fun, let's see what happens as t goes all the way out to 10. So I'm going to calculate x of 10, which would be 3 minus 10 squared, and y of 10, which would be 2 times 10. So this would be 3 minus 100, so 97, and this would be 20. So I really, at the end of that curve that we couldn't see, I should have the point 97, 20. So I'm going to change my standard viewing window, my x min to be, let's see, what did I say? Oh, this would be negative 97. So I'm going to change that to negative 97. And then I'll change my y max, since it's only at 10 right now, I'm going to change it to, I want to see 20, so maybe 30. So if I hit trace, and I want to see what happens when t equals 10, there is my point, negative 97, 20, just like I had predicted.